so this page is not in your packet. I realized afterwards I'd forgotten it. But you don't really need to write everything down. What we're going to do is we're going to take these first 6 right here, and we're going to graph them. And if you take the last page of your packet, you have grids. So all you're going to do is take a piece of paper right now and write down this equation. Okay? So we're using the grid at the back of the packet. You're just taking a piece of paper and you're going to write that equation on it. Pause if you need to. So what we want to do whenever we look at this is in standard form. So this is in standard form. When it's in standard form, well, with any of them, we always start off to determine what way does it open. See how there's a negative? So this one's going to open down. And if it opens down, and what I like to do is just kind of sketch it, if it opens down, okay, my vertex, is that a max or a min? That's going to be a maximum. Okay? If I'm given standard form, one of the first things I have to do is I have to find the vertex. So, to find the vertex, remember that the x-coordinate of the vertex is negative b over 2a. So negative b, so a is negative 1, b is negative 6. So I'm going to get negative 6 over 2 times negative 1. So I get 6 over negative 2, I get a negative 3. So my vertex so far is negative 3. Next thing I'm going to do is I need to find the y-coordinate. Well, if this is my x-coordinate, what do you think you do? Exactly, plug it in. So y is equal to negative 3 squared minus 6 times negative 3 plus 2. Pull out your calculator. This is going to be a negative 9 plus 18 plus 2, so that gives us 7. Hopefully I did that right. Okay. That's our vertex. Let's go to our grid now. Oops. See if we do it this way. So, our vertex is negative 3. 1, 2, 3, 7. 1, 2, 3, 4, 5, 6, 7. So the x-coordinate is negative 3. The y-coordinate is 7. 1, 2, 3, 4, 5, 6, 7. Hopefully you can see that. Now, that's your axis of symmetry. So now we're going to use that axis of symmetry, and we're going to come up with more points. Well, the easy one, take the y-intercept. Remember, if the y-intercept, if it's a standard form, I'd plug 0 in here. Those will both drop out. So my y-intercept is 2. So that would be 2 is my y-intercept, but I should write it as an ordered pair, 0, 2. On the final exam, sometimes we ask them as ordered pairs, sometimes we just ask them as numbers. So just pay attention to what we're asking for. So my y-intercept is 2. Here's my y-intercept of 2, right? Well, remember I want the reflection point. So go over 1, 2, 3. So I'm going to go over 1, 2, 3. Here's my other point. Now what we should do is we should just pick an x value and see what it's going to be. We can't use 0, so I'm going to use a 1. I could use a negative 1 and be right here. I'm going to use a 1 just because. So I'm going to plug a 1 in. I'm just going to use my paper here. So y is equal to 1 squared minus 6 times 1 plus 2. Negative 1 minus 6 plus 2. What is that? 3. Negative 6, then a negative 3. Yep. So 1 and 1, 2, 3. Reflection point. 1, 2, 3, 4. So go over the other way. 1, 2, 3, 4. Here's my graph. Okay, this is where it is in standard form. Now, I'm going to leave this number 2. I'd like you to do this one on your own. If we have time, we'll come back to it, but I want to make sure that we get to some other things and I don't take as long. So, that'd be a good one for you to try on your own. If we have time, we'll come back to it. Okay, number 3. Now, on number 3, we're given in vertex form. And in vertex form, remember, is y is equal to x minus h quantity squared plus k. H is your x-coordinate of your vertex. K is your y-coordinate. So my vertex here, because it's subtraction, we actually want subtraction. My vertex is 2, negative 3. Does it open up or down? That's right, it opens up. It opens up. Okay? And, oh, we have A. A is a 1/2. So if this is a fraction, it's going to be wide. Okay? Now, what this also tells us, that's our vertex. So we could just start there, plot the vertex, and then go. But we could also use our shifts. That's what I like to do. So I'm going to do the shifts. So this one shifts right 2. And remember, that's because you want a minus. If it's a minus, it's going to go the opposite direction. And this tells us it's going to go down 3. And it's going to have a shrink of 1/2. Okay, let's plot our parent function. Then, so I'm going to go to the piece of the grid paper now. Okay, and I'm going to do the shifts. And remember, in order to start with vertex, what I think is the most fun too, is that we actually plot the parent function. And this one opens up, right? Yeah, if it opens down, I sometimes do the parent function down. So there's 0, 1, 1, negative 1, 1, and 2, 4, 2, 4. Okay, that's my parent function. Remember, we don't draw that in. Now, what I'm going to do is, I'm not going to do my shifts yet. I'm going to do my shrink. To do my shrink, what I do is I take my y values. My y values are 1 and 4. And I apply the shrink of 1/2. Sounds like it should be a movie or something. A boring movie. Okay, good thing I'm a math teacher, not a movie writer, huh? The shrink of 1/2. Okay, so now I'm going to shrink that. That's going to be 1/2. 1/2 of 4 is 2. I'm going to now put x's on for those shrinks, and then we're going to shift it. So if I put x's on for those shrinks, in place of 1, it's going to be 1/2. I can't put an x. I'm just going to put a line. So that's my shrink. And then this 2, instead of going all the way up to 4, it's only going to go to a 2. This I'll put an x on. So this parabola, see how it's wider? Now we're going to shift it. So I'm going to go right. So this one's going right 2. And remember, the vertex doesn't shrink because 1/2 times 0 doesn't change it. It's just 0. So now I'm going to go right 2 and down 3 with every point. Right 2, 1, 2, down 3, 1, 2, 3. And I'm going to go right 2, 1, 2, down 1, 2, 3. Just stay halfway in between. And right 1, 2, down 1, 2, 3. Just kind of stay in that half point. Now I'm going to go right 1, 2, down 1, 2, 3. 1, 2, 1, 2, 3. And notice too, our vertex was 2, negative 3. See how it's 2, negative 3? So this is what our graph looks like. Okay. And again, I'd love to have you do number 4, but if we have time, we'll come back to it. I'll probably get there. Okay, number 6. This one's given in factored form. And factored form means that, okay, well, let's just write out factored form. X minus P, X minus Q. Okay, and factored form gives us our X-intercepts. Okay, so our X-intercepts. If all I ask for is the X-intercept, I could, and if they say what is X equal to, X is 5 and 3. If they ask for an ordered pairs, I would write it as 5, 0, and 3, 0. So just watch on the directions for the final. Okay, sometimes they ask for the X-intercepts as ordered pairs. Sometimes they just want to know what are the X-intercepts, what are my X values. So just watch that. And this one does. See how that's a negative? So this opens down. Oh, we forgot to state this one was a minimum. This one's a minimum because it's going to open up. Well, we saw it opens up. So this is my minimum down here. So this one's a minimum. This one opens down again. So this one has to be opens down. And it's going to be a maximum then. Okay. Now we have enough we can actually start graphing. That's the beauty of a factored form one. So I'm taking my paper, and I'm going to fold it just so then you can still see it. And I'm going to plot my X-intercepts. So 3, 1, 2, 3, and 5, 3, 4, 5. Whoa, this is going to be narrow. Well, yeah, it's going to be fairly narrow. And it opens down. Now on this one, remember, we have to go through and find the vertex. You have to use your axis of symmetry, which is halfway in between your two X-intercepts. My X-intercepts are 5 and 3. 1, 2, 3, 4, 5. So my line of symmetry is right there. My line of symmetry, I don't know if you can see it, My line of symmetry gives me the x-coordinate of my vertex. Those always match up. Axis of symmetry is the x-coordinate of your vertex. So my x-coordinate of my vertex, I'm going to go back up here. X-coordinate, so axis of symmetry, I should be writing those out, is x equals whatever x is, 1, 2, 3, 4, because it's halfway in between. So my x-coordinate of my vertex so far is 4. We have to now take our x-coordinate, plug it in to find the y. So we're going to take 4 and plug it into our equation here. So y is equal to negative 4 minus 5 and 4 minus 3. That gives me negative 1 times 1. That gives me a positive 1. So I plugged in 4. This is what I'm plugging in because that's my x-coordinate of my vertex because that's my axis of symmetry. So my vertex is 4, 1. Ooh. Okay, we're going to have to find another point. Now, here's the beautiful thing. I think, let's see, nope. I was going to say we could find our y-intercept by plugging in 0, but look, we're going to have a 5 times a 3. It's going to be 15. That's off our grid. So I'm just going to pick another one. Let's pick 1 for x. Let's pick 1 for x. So I'm going to pick 1 and plug it in for x. Y is equal to negative 1 minus 5 and 1 minus 3. So it's a negative 4 times a negative 3. I'm sorry, did you see all that? So negative. I plugged in 1 to my original equation. So I have negative 4. 1 minus 3 is negative 2. So that's going to give me a negative 8 because I have 3 negatives, so I know it's a negative 8. Okay, so we plugged in 1. So 8, 1, 2, 3, 4, 5, 6, 7, 8. Now we can go back to that reflection point. See how it's 1, 2, 3 away from the axis of symmetry? Go the other way. 1, 2, 3. So there is our parabola. Okay? Good. Okay, and again, try this one on your own. Okay, number 9. These are just kind of fun. This is just trying to find out if we remember our transformations. Okay? So if you look at it, we have one that opens up, one that opens down, one that goes wide. These are our 3 equations. We know that this one, oh, these are just all based off the parent function. These two are. This is our parent function. It opens up. It's just normal. So that one's got to be, but it opens up normal. So 1, 1. Hey, that's not either one of them. I wonder if this was supposed to have a negative right there. Because C is, if we go y is equal to negative x squared, and the reason I know that is because here's 1, 1, here's 2, 4. I think there was supposed to be a negative there, because that's C if we put a negative in. If we don't have anything that matches it. Okay, now this one, y equals 3x squared. Well, this one's narrow, this one's wide. Remember, if this number is big, okay, it's going to go wide. So this one is A. Now, if you ever forget, you can just take the points and plug them in and see which graph it is. So I could take and plug in, where's a point right here? Ah, that's negative 1, 4. I could plug it in and see which one it was too. Okay? Ooh, well, that wasn't a fun activity. Let's look at this one. So this one hopefully does it a little bit better. And I know you cannot see all of that as well as I'd like you to. But, okay. So here we go. What this is telling us, this one opens down. So figure out which one opens down. Let's name this A, B, and C. Which one opens down, people? C opens down. So now we have to decide on this. What's the difference between these two? Well, they're both 2. My x-coordinate of my vertex, both negative 1. But look how the shifts are. See how this shifts right, this shifts left 1. This one goes up 3. So left 1, up 3. This one is left 1, down 5. Okay? But they both open up. So A is this one that opens up here. That one shifted up 3. So that one shifted up 3. That's got to be A. This one shifted down 5. So this has to be C. B, 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 because this one is B. This one is supposed to be B. This one's supposed to be C. This one, what it's asking about is shifts, which you saw in the EOC test. Okay, good, great. So that was graphing, review of graphing with quadratics. So let's go back up and pick up 2, 4, and 6. And again, please, please, please pause yours, try it, go through, look at what we did over here, look at what we did over there. Okay, try it on your own. So I'm going to start making notes. Hopefully you've paused yours. Okay, if not, pause it now. Go through and make some notes just like what we did before. So hopefully you've already found out that the vertex is -2, -4, and I found that by using negative b over 2a. That's something you're going to want to memorize for the final. Negative b over 2a, found out that the x-coordinate was -2, plugged it in and found out the y-coordinate was -4. I'm going to now go to my graph and start putting some of that stuff on there. Okay, so I'm going to line it out a little bit. My vertex is -2, -4, -2, -4, 1, 2, 3, 4. Okay. My axis of symmetry. Y-intercept, what's a y-intercept? It's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, find your reflection point. Personally, I think that's enough. You can plug in 1. Let's plug in 1 just for the heck of it. So 3 times 1 squared plus, so that's 3, plus 12, plus 8. Oh, hey, hello, wait, don't do that. Plug in -1. So it's going to be a -12. Because you're going to have 12 times -1. So that's a -12. So is that 1? 11, -1. So -1, -1. Okay. So what I did there, I plugged in -1. And I got a -1. There's 1 point. Its reflection point's right over here. So your graph looks like this. And it's going to be fairly narrow because your A was 3. See how that tells you that your A is 3? So it's going to be narrow. Good. Now, try number 4. So on this one we have a opens down, so it's a maximum. Shifts are -2, because remember we have to go opposite, and it's going to go up 3 with a stretch of 2. And I know it opens down, so some people would say stretch of -2. I'll let you decide which way you want to do that. Okay, so I'm going to take and graph that, what I know so far. I'm going to put in my parent function. Okay, if y'all don't mind, so my parent function would go up. It'd be, okay, I'll just do it. And then 2 and 1, 2, 3, 4. To tell you the truth, if I were doing this without showing you, first thing I would do is I would open it down. So here's my parent function opening down. So there's my parent function. Now that's my parent function, but I have a stretch. So my y values, okay, are -1, -1, -4. I have a stretch of 2. So either you have to go off your parent function of 1 and 4 and stretch it to -2. I like to do it this way, so I get a -2 and a -8. So I'm going to now stretch those. So -1, what this means is -1 for my y value. This point right here goes all the way up to -2. This one, where my y values were -4, go up to -8, 4, 5, 6, 7, 8. So this y value of this point stretches all the way up. I now have my stretch. We're going to go and do our shifts. Hopefully you already did all this, and let's just compare at the end. That's both, okay. I'm going to go left 2. So my graph looks like this. Okay, good. Okay. Number 6, write down what you know. Start it, try. So I know my x-intercepts are 2 and -4, and I've plotted those at 2 and -4. I want to find my axis of symmetry, so I'm going to go halfway in between, and I just move my fingers in. Halfway in between. Did I do that right? Is -1. So my axis of symmetry is right here. Now, if your axis of symmetry is not coming up great, take your 2 intercepts, 2 plus -4, and divide them by 2. So I get -2/2, which is -1. Hey, you'll be doing that next year, finding the midpoint. That's what you're doing. This is the formula for a midpoint. Take the two values, add them together, and divide by 2. So that means that my x-coordinate of my vertex is going to be -1, because it's the same as the axis of symmetry. Axis of symmetry, remember, x equals whatever x is, so -1. We're going to take that and plug it in to find the y value of the vertex. So I'm going to take y is equal to -1 minus 2, -1 plus 4. That gives me a -3 times a 3. That's going to give me a -9. Woo! Barely makes it on our graph. So our vertex is -1, -9. Here we go, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's our x-intercepts. Here's our vertex. I'm good with that. If they're really close together, I like to kind of find some other points. And yeah, I probably should. Your next instructor will tell you what you need to do. Good. Okay, so if you have any questions, you know where to find us. That's the end of the second part of review.